So what's in the box, you ask? As we can see on the box here, we have some tape that says bathroom. We have some tape that says bedroom. And I guess technically you could put this thing in like either one, but you could use them in both simultaneously. And we'll see why. What's funny is that on the box here, we see we've got some arrows, and then up here on the top is printed top. The viewer that sent this to me, who goes by the name of Griff in Cypress, Texas, extremely generous donation this is, and we're gonna take a good look at it. Anyways, he told me that he put this stuff here, you know, basically to signify that this is the top side. However, in shipping, this thing probably like ended up like every single which way and upside down and whatever. So, but then he also mentioned that he thinks this is the top, but he wasn't sure. So we're gonna find out if that is the top section or not. So let's just go ahead and open this and take a look inside. We're just gonna slice dice the bottom right here, and we're gonna try to see if it'll come out the bottom. See, it's nicely wrapped in bubble wrap, so that's good. Looks like really good bubble wrap, actually. Wow, there's the back of the unit. This was the top after all, so no worries there. Get the bubble wrap out of here. That's more bubble wrap, more bedroom tape. Okay, I hope I'm not going to drop this here because I don't have much room. So let me just dump it out the side. Slide out, yeah. Okay. There we go. Okay, let's take this one off here. Well, actually, now we can see what it is. This is a Niles SI-1230. It's a systems integration amplifier. And if we turn it around to the back, it's a 12-channel amplifier. So we see we got 2 here, 4, 6, 8, 10, 12. So apparently the problem with this thing is that there's something wrong with, I think, 2 of the channels. One thing that kind of sucks about it though is that apparently there's like no way to get a service manual for this thing, so we're going to be kind of going in blind. I have no idea if like any of the parts inside are like custom numbers or what, so really don't know what we're going to be able to do. He said that couldn't get it working and just decided to donate it to the channel. So once again, like many thank yous. This is it's going to be really cool. So let's see what we can do with it. Yeah. Oh man, there's a lot of bubble wrap. At least I know it's pretty well protected. Oh, check it out. We can already see some stuff inside of here. A big toroidal transformer right there. There's quite a bit of empty space right here. But then there's also a huge heatsink here, so this whole thing is passive. Doesn't look like there's any fans. So all of our amplifier modules are going to be right here towards the back. Looks like it's all sort of kind of modular. There's a board down there that looks like it's filtering for the power supply and the power switch and everything. And so a lot of the weight is coming from that little toroid right there. Or little. That thing ain't little. So let's go ahead and remove the screws. Take a better look inside. This thing looks like it's in pretty good shape. So I don't know. Hopefully there's like not any serious damage inside. And like I said, hopefully no like crazy custom part numbers. Okay, all the screws are out. There was 15 fairly large screws, and then there was 2 really small ones that kind of went up here in the front. So now this cover should come off. No issues. Let's see. Front here feels like it's sort of latched. It must have like a little lip on the cover. It's coming off. There it goes. Wow. That's a fairly... Oh, it's actually 3 heat sinks, so it's not... I thought it was just a single one. But there's actually 3 heat sinks right here, so... Well, good news is that the amplifiers themselves are actually National Semiconductor numbered parts, so that's cool. That would be fairly easy to figure out. It really looks like there's not a whole lot of custom stuff in here. It all looks pretty kind of vanilla jelly bean sort of stuff, so that is really promising looking. And each one of these boards right here is a separate module. I cannot tell which one was the one that had the fuses replaced from what I was told. Yeah, I'm not sure, but yeah, so we've got 2 amplifiers on each one of these boards, so that means that each one of those amplifier They look like a zip 15 sort of package, or 10 pins. I'm not sure. I can't really tell exactly how many pins are on there. It looks about 10 or so, 10 or 11, something. Anyways, let's turn it around here. Let's look at this big fat toroid. So we've got input of 120 volts, 60 hertz. Tells you right here where all the colors are. This is really cool. I really was not expecting this thing to have, you know, like everything printed on, so actually we can tell to see if these voltages are all present there, because you can see we have 21.4 volts right here, so this would be the output. Black, blue, and black. So it looks like it's got at least 6 different windings. 6 windings center tapped, yeah, so holy monkey. That is, look at all the cables coming out of it. Wow, so they really weren't like using one set of windings for like everything else, you know, like center tap, because that's usually how it is in like these push-pull amplifiers. They'll have like one winding, that center tap, that'll be for like feeding all the audio amplifiers, and then there's going to be like a secondary winding that's usually like a single winding that's used for powering like the preamps and all that stuff, or the like the lower signal amplifier, like op amps and all that stuff. So it looks like here what they did is they just have one set of center tapped windings for each amplifier on the thing. So that's crazy. Got some fairly beefy fiberglass sheathing right here. This stuff is thick. So they really wanted to protect these wires right here from getting scraped against the heatsink. So that's some pretty good safety right there. Not much over here, but everything's kind of zip tied, so it kind of kept out of the way. So, well, that's cool. At least we can check the windings, make sure that they're all putting the right voltages. Let's flip it over to this side. Oh, there's some fuses. I just saw those. Totally missed them before. So we got some fuses taped right there. I guess he decided to include them just in case, so thank you very much. This is the little indicator board. We see we've got some 3 LEDs right here. We got a red, green, and a red. There is the power switch, and it's one of the clunky types. So this looks like it's going to be cutting power off from the mains input. As we can see, the mains input comes from here. It's an IEC terminal, and it looks like it's not grounded, so it's just just the live and the neutral there. There is no ground terminal. So we see we have our neutral and our live. They both come up to that power board right here. There is a relay. There's a small, looks like a small power transformer there. That's probably just taking care of like running this stuff up in the front there. It looks like we have a few diodes right here. We got a fuse. Let me get the light up in there so you can see it better. So perhaps on this board here, this might also be sort of like a little safety board. If it detects that there's something wrong with anything on either the amplifiers or the voltages coming from the transformer, maybe it does not allow it to power up. There is a small 3-pin terminal right here, and this is actually going to the amplifier as well. As we can see, it kind of goes along here. It goes over to the boards there. I'll flip it over and I'll show that better. So this could be supplying some sort of a feedback that if there is something wrong with the amplifiers, it doesn't allow power from the mains to get to the transformer, which actually goes through these wires right here. So that's just like a single coil right there, or a single winding on the transformer. We can apply power to the mains. I can leave the transformer disconnected for the time being, and I will also disconnect this here. And obviously this is not going to be providing any feedback to this board, and we can just see what this board does. Or maybe I should, well, since it doesn't work already, I guess there's really no harm in just switching it on as is. And we can see if we're getting any power out of this terminal right here for the big transformer. Obviously we should be getting something here, because there's nothing fused on this end. There is a fuse down here. So we can see if we're getting power up to this point here. And when we hit the switch, we'll see if these LEDs do anything. As I mentioned already, we're kind of going into this blind because we have no service manual. There's apparently no way to get a service manual for this thing. I mean, there is an operator's manual and stuff like that, but that's obviously not going to give us like any details about the electronics inside of the thing. So we'll get the multimeter out and we'll start from there. This is the first time I've ever messed with one of these things, so I really don't know too much about it. and I have not like looked up any details or anything. Like I said, I didn't want to. Everything basically here is I'm just doing it kind of like brand new. I don't really want to spoil anything for myself, and we're all just going to kind of take a look at this together. But what we can see, what we have here is these are several inputs. This is the main bus input. I'm guessing that's going to be like for every single thing over here. I don't know. There's some dip switches here that I guess you can select from where you want your audio input to come from. I'd have to look at the manual. So right now I'm just kind of like making assumptions, and I'm just telling you that right now. So if I get something wrong here and somebody really knows how these things operate, you know, once I figure it out, maybe I'll leave like a little correction like down here in the text somewhere. But if I screw up on something here and I mess up and you know how these things work better, you know, just feel free to leave a comment below. You can correct this. That's cool. And this here says Cascade Bus Output. So I guess this would be like if you want to attach it elsewhere, like another amplifier or something. We have a little switch down here that says we can have it turn on with audio sense if it's constantly going to be on. So I guess this would be like if it's sitting on the constant on, then if you have the power switch on in the front, then it would just, you know, be running all the time. Audio sense, you would set it so that if, you know, the amplifier is powered up at the front, but there's no audio coming into it, then it would just shut off until it detected something. And then there's a third option here that says 3 to 30 volts AC/DC trigger input, and that's going to that little jack right there. It looks like an 1/8 inch jack. So this could be basically like a remote trigger. So if you want it to be controlled by something else, then I guess that's what you would use that for. This here says 12 volt control out. So that would probably be so that when the amplifier is powered up, whether it's be from the constant audio sensor or the trigger, you could also control something else from that output right there. And if we keep going on here, we see we have these look like these are like the gains or the levels for each individual amplifier. You can bridge them apparently. So this would be the bridge negative and the bridge positive from what's labeled on here. It says 4 ohm minimum, 8 ohm minimum in bridge mode. So you wouldn't want to have like a 4 ohm load in the bridged mode. Otherwise, you know, if you just have it not bridged, then you would have like one amplifier here, another here. I do not know the specs of the amplifiers off the top of my head, and I have not looked them up, so I don't know what it's capable of. But they look like, I guess I could look that up real quick. It's an LM3886T. So they're using 12 of those amplifiers, 2 on each of these amp boards. These dip switches here, no clue how these operate just yet, so I'm gonna have to look all that up. But basically each one of these sections is completely identical to the adjacent one, so everything's exactly the same. If there's something wrong with one of the amplifiers, we could use one of the other ones to, you know, measure it or whatever. And as we can see that the IEC port here, or the IEC connector, only has the live and the neutral. It doesn't have the ground pin in the center. I plugged in a cord right here in the back, and this should be powered. Yeah, it's plugged into power there. So let's go ahead and hit the switch in the front, and we'll see what these LEDs do. But I guess we should figure out what they are first. Let's see what we got. We have power on the first one, we have active on the second one, and we have protect on the third one. So let's see what lights up when we hit this switch here. Dim this light a bit here. I'm going to point it away so we can see the LEDs. Okay, let's hit power. Power active is off and protect is on. So power and protection are on. So there's obviously something wrong. And it sounds, I don't know if you could hear that. Let me get the mic in a little closer. It sounds like that relay clicks on for a second there. But then it sounds like it might shut off. So I'm going to just gently click the switch so that the noise from the switch itself doesn't cause you to not hear the relay. So listen to this. Yeah, so it sounds like the relay clicks, we hear the transformer buzz, and then it goes into protect mode. So it seems like maybe one of the amplifiers might just be shorted, which would make things kind of easy. Let's disconnect one of the power leads going to the transformer from here. Then that way the transformer gets no power at all, and it should not power up. And let's see if that still triggers a fault in this front board here. So right there, as you can see, I've disconnected one of the transformer. leads going to the transformer. Let's go ahead and hit the power button and see if we get a click. Yep, no protection. So, oh, anyways. So yeah, definitely some sort of a signal is coming back through this line here, or it's detecting an overload condition of some sort, but it doesn't look like there's any shunts or anything on this board, so I'm not sure about that being the case. Plus, I think that would be not enough time for it to detect a short, because there's always going to be a kind of a high inrush going to the transformer as soon as it powers up, so that would probably trigger like an overload condition under pretty much any circumstance anyway while it's charging the caps on the amps. So let's get the meter out and see what we can find. Alright, so what I can tell from here is that the fuses from the first amplifier module right here have been replaced. So it's looking like that's going to be our problem module. If any of the other ones have an issue, I don't know yet, but that's the only one here that has obviously had something done to it. Everything else looks original, so no other components have been replaced. So let's check the outputs here and see if any of these are shorted, or like if there's an obvious short. And nothing there that we can tell. Nope. Switch these around, I'll probably get a beep. Nope. Let's change the range here to 3K. Nothing. Nothing. Nah, that would just be like capacitors charging right there, so I guess whatever the problem is may not be a direct short with the or in the amplifier module. Okay, I guess we're gonna have to remove it. Well, let's check the other ones. So let's just check all of them and see if any of them have a problem. Okay, so there's no direct shorts across any of the outputs of these amplifiers. We could disconnect all the power leads coming from the transformer, power it up, and make sure that it's not the transformer that has a direct short in it somewhere. No, that would be kind of, I mean, it doesn't look like it's overheated or anything. It looks it's in pretty good shape. One thing I did notice here, and we're going to see it, if I have to pull these amps, we're going to see it better, is that there is a 3-pin connector on every single amp module, but only the first one is used, and I think that's the power from the rectified voltage from the transformer to power up the board back here that, you know, has like all the preamps and everything, because that's this cable right here, this 3-conductor cable, goes directly to this board. The connector actually, that little bundle actually runs up to here, and then it goes down. And there's also the other 3, I'm not going to be able to see here, but there's the other 3-conductor connector that goes up to the front. So I'm wondering if this is just detecting like the positive and the negative rail. So like maybe one of these is ground, the other one's the positive side, and the other one's the negative side. So I'm not entirely sure yet. Don't know exactly how everything is wired. Although, I don't know, that might not be the case, because we do have the switch right here, and this is the only 3 wires going to that front board. So that front board there is probably the one that's doing all the detecting from this back here to power it up, and, you know, depending on whether if it's got the audio sensor or whatever. Maybe there's something coming from that board over to here as well. I really have no idea at the moment, going in blind and all that. But now that I've disconnected all these here, I'm just going to make sure they're not contacting anything else. I'm just going to leave them unplugged like that. I don't think there should be any problems. I will disconnect this one though, because the toroid operating by itself should not be a big deal, but we're not going to feed anything else to these boards. And let's see if it stays on. Okay, so I have nothing plugged in over on this side. The only thing that's plugged in is power going to the switchboard in the front, and the power going to the toroid through the main winding right here, the primary winding. Nothing from the secondary side of the toroid is connected at all. So let's see if it stays on. If it doesn't, then that could mean that there's a short inside of the toroid itself, but let's see. Nope, it's still on. So toroid appears to be completely fine. We could see if we are getting a short at any of the input terminals on the amplifier modules. Each one has a 3-pin connector, as we can see. Maybe one of the diodes in a rectifier or something might be shorted. You can see right there, that's what the amplifier looks like. It's just that board right there. There's the 3-pin connector I was talking about. So this would pretty much be going to power the board in the back. There's the 2 fuses. We can see we got 2 big caps right here, and every single board has 2 big caps like that. Those are, I can't read them. the values are, it's kind of hidden like right here on the side, so I can't really tell what they are from this angle. No worries. Alright, so let's check the input connector here and see if one of those is showing a short or not. So what we're seeing here is we're going to check between the blue and the black, and then the blue and the other black, because the blue one is the center terminal. This here, now showing several megohms, so that should be fine. That's showing a lot of megohms, so that should be fine. Okay, doesn't seem like there's a problem there. Yeah, at this point, I think we're probably going to be better off removing the amplifier. Looks like if I remove each screw from each one of these sets of banana connectors here, well, they're actually like screw-down terminals and banana. Each one has a screw in the middle, and there's also a few screws in here on the bottom. It looks like if I remove all that, this whole backboard here should separate from the amplifiers, because each amplifier also has two sets of 3 pins, headers that are plugged into the 2 separate points on this backboard right here, and that's on every single amplifier. So that should, looks like, allow me to remove this back panel. So let's see if that's true. Okay, I've removed all these screws, and I've unplugged the 2 connectors here in the back of the IC plug. So, oh yeah, came right off. This little cable here though is a little tight, so I'm gonna have to be careful with that. There's the other cable I was talking about that goes to the bottom board here, but it looks like I should just be able to unplug this from the bottom. That's that. I will swing this over to this side. I should be able to unplug this one from over here too, but it's behind this other board, so it's a little more difficult. So we've got a couple of other regulators on the back here. This one looks like a transistor. That looks like a 2SC4793. This one here is an LM317T, so that's an adjustable regulator. And there's a 337T over here. So these two here, one's going to be the positive regulator, the other one's going to be the negative regulator. So they're taking the voltage input and they're splitting it off into like a lower positive and negative rail. I don't know, maybe like 15 or 18 volts or something, I'm going to guess. The other one over here, I don't know what's going on with that one. You can see there's some like 14 pin devices right here, so those are probably going to be our op amps. Don't know what they're using because I can't see it. This is the small input board here for power on selection, and there's our amplifiers. This is the 3-pin connector I was talking about that's plugged into this bottom one, so I'll just unplug that. It looks like, let's see, is there screws on the bottom? Don't feel any screws on the bottom. Oh yeah, there is some screws on the bottom, so I'll probably have to flip this up. There's 2 screws holding each one of these heat sinks in place. So there's 2 up here on this bracket that also holds the top cover on, and then there's 2 on the bottom. But it looks like I might not need to do that. Maybe if I just remove the 2 screws here holding the amplifiers, I can pull this entire board off. So that should be no big deal. Yeah, because it's just kind of flapping around in the breeze now with nothing else to hold it in place. Okay, so there's the amplifier board. And as I mentioned, all 6 of them look like this. They're all identical. We see we've got the connectors, the banana plugs, and just soldered directly to the board. So very simple amplifiers here. Nothing extremely complicated going on. There, other than the 2 amplifiers, there aren't even any other semiconductors on here. Well, I mean, other than the rectifier bridge right there. But so it's getting its audio inputs from these connectors. I don't know if there's actually any feedback from those, like going out to the the board in the back there with like the preamp and all that stuff. It's possible. Not entirely sure how these are wired up just yet. I still have not looked up the data sheet for these, so I'm going to have to do that before I can, you know, actually figure out what, like, what's supposed to be an input, what's supposed to be. I mean, the outputs are pretty easy and the voltage ones are pretty easy, but the rest of them, you know, got to figure out which one's like an input, which one's supposed to be for like a, say, like a feedback pin or like inverting and all that stuff. Not that it would be terribly hard to figure out. All these little capacitors right here are probably going to have to do with like audio. We see we got a couple of coils right here, or inductors for, those are probably for the, yeah, those are going straight to the outputs. So very kind of basic stuff. But what we can do at the moment is we can hook up the meter across these capacitors and see if one of those is showing a short at all. I should probably make sure they're discharged first. So let's see what they're showing. This one is showing, oh, that's like 0 volts, and this one's showing, it's like 0.3. So we're good. Let's put it on ohms here. Let's move this over so you can see it. 3.7 megohms, so that looks okay. 6.495 megohms, so that looks okay. It doesn't look like any of the amplifiers are shorted. Huh. Interesting stuff. We're going to look at this better in a minute here. What I'm going to do is I'm going to look up, well, actually I already looked up the data sheet for these amplifiers, and that's supposed to be like a, well, the first one that came up was a TI part. So these are national branded, but it's supposed to be like a 68 watt one channel amplifier. So each one of these is a single channel amplifier. And I'm going to reverse engineer this a little bit. I'll come up with the pinout for these three right here, and I at least have, like, you know, a bit of an educated guess of what's supposed to be happening. So we'll look at that. We're going to come back to this in a minute after I do that. But what I wanted to do is I want to apply power to the transformer. Holy monkey, I just noticed this. These two right here, I didn't unplug. I just unplugged the side from the IEC cord over here, but like in wiggling around they kind of came off. Are these not? Dude, these were like barely on there. Yeah, like it doesn't look. I'm gonna get you in closer here. It did not take very much effort to pull those out. See how they're like kind of way up there? Like this would have to be like pushed up, this sort of silicone covering on there. So it just kind of goes in that far, and then see, I'm able to pull it out with like very much effort. Same thing on the other side. Well, that's not cool. Although I don't know. Yeah, I mean the front board was powering up, so I don't know that this would have actually been part of the problem. Yeah, I think while I was like kind of wiggling this stuff around is probably when I unplugged it. So it really does not take much effort to unplug. So yeah, that's no good, but that's an easy remedy. So I'm not too worried about that. Anyways, what I was trying to get at over here before I noticed that was that I'm going to unplug this 3-pin connector here from that little, well, actually this one goes to the top board there. But to do that, I have to remove this little board on the bottom there. And to do that, got to remove these nuts off of these two jacks. So once I can move that out of the way, I can pull this off to figure out like what each one of these 3 wires is supposed to be doing. Although, I could probably do that by checking this one over here, actually. I'll just see like what those wires are, you know, connected to on this board, which would be way much easier. So I think I'm going to do that. I'm going to pull this board out, take a look and see what's all on it, and see what each one of these 3 conductors goes to. One of these is very likely to be a ground. So that's pretty much a given, seeing as how there's like nothing else going from this board to like the back section here. Quick change of plans, or just a small little sort of a little detour here, because we should always check voltages first just to make sure that there's nothing wrong with it. I really should have done this a while ago, but I didn't, because I was just expecting to see like a short or something at this point. But we're going to check the voltage coming out of all these connectors here from the transformer. I do not want to assume that there isn't anything wrong with the transformer just because it looks okay. So I'm going to check all 6 of the outputs and make sure that they are all, you know, outputting something close to what it says on the transformer itself. So we're looking at 21.4 volt. No, I mean it would be 22 2.8 with a center tap. So between the blacks on each connector here, we should have about 42.8. And if we measure from the blue to the blacks, you know, then we would see 21.4 or close to that. Okay, transformer looks to be entirely in good shape. Each winding is, well, from the center tap to the outer winding, all of them are showing like about 21.2 pretty much on each one. If I measure across the ends of the windings, then we're getting like the close to the 48.8 or 42.8. So absolutely no issues with the transformer that I can tell. And like I said, I didn't think so, but we just need to roll it out. Alright, so now this board is out. The only thing holding it in was 4 of these machine screws with a split washer to kind of clamp it there, but that's it. There is nothing on the bottom side. We can see that this is where the mains comes in. These 2 terminals, and one of them goes to directly to the transformer. The other one goes to this transformer. That looks like it's our neutral. So the neutral goes directly to both transformers, the toroid and the small one here. The second, the live, goes to the fuse. That fuse right there goes to the other side. It goes through this mauve right here. Looks like a mauve or a... yeah, I think that's a mauve. And then it just kind of jumps across. And this goes to the relay. So it goes to 2 of the points on the relay there. The other side of the relay goes to the contact for the toroid. So this relay is only controlling the toroid over here. The other side of that just goes directly to the small transformer. So then the output of the transformer is just two pins right there. Goes to this little full bridge rectifier down here at the bottom. So that's only for like powering this section. And there's really not like any logic or anything on here. There's just 2 little transistors. These transistors, the traces, some of these you can kind of tell that they go off to this connector here. So I'm going to just quickly reverse engineer that part there. That should be really easy to do. Everything else that's on here, we just see we got a couple of electrolytics right there. We got some resistors. Those are probably going to be for like current limiting on the LEDs, because it looks like that's what it goes to. So nothing complicated. Some diodes. These might be Zener's or something, not entirely sure. They're probably being used as like some sort of a reference, so that if the proper voltage isn't present at this input here, then these transistors know to trigger or to not allow the transformer to power on by keeping this relay shut off. Funny part was, when I disconnected this, there was still a charge apparently on this capacitor, because I hit the power switch and I heard the relay click on for a sec. It just went like click, you know, because it didn't have enough of a charge to keep it on continuously. So the relay, when the power switch gets, you know, that's interesting. I just realized that this power switch doesn't cut off power from the mains. It cuts off power from the secondary side. That just hit me. That's interesting. It actually looks like, from what I can see on the traces here, it looks like this switch goes directly to one of the windings on or one of the pins on the relay. See, in here I thought that this was controlling the mains input coming in and just cutting it off straight, so it's really not. So as long as this thing is plugged in, this transformer is always on. Well, it doesn't matter, because I mean, we're still getting it. This relay is not keeping the transformer on for whatever reason. I'll just drop a quick schematic for this area and we'll figure that out. Alright, so we're back here and I've got a schematic now drawn of this board. It turns out that it's really not that complicated, but I ended up having to remove the relay and the transformer from the board just because some of the traces kind of ran underneath and it was a little bit difficult to figure out where they were going. I mean, I could have done like a continuity test, but it was a lot easier just to see it. One thing that, I don't know if you'll notice here on the transformer, is that the pins are pretty symmetrical on both sides. So when I took it off, I'm thinking like, ah, shoot, now I got to figure out which way it goes. Well, there's 2 ways I could have done that. One is by looking at the bobbin here and noticing that the windings on this side have thicker wire than the windings on that side, which is much finer. Or the second way is that the board is actually labeled blue and red, so it makes it really easy to figure out which way it goes. So I mean, the transformer will fit on either way. Like I could put it in the wrong way, but then of course I'd probably end up blowing the fuse just because the winding on this side is much lower resistance. But it's, yeah, that's pretty cool. And then the relay is just a regular relay with 2 contacts. I mean, it's got 4 pins over here, but technically these are one set of contacts and that's the other set of contacts. So let's see what we got here. We'll look at the schematic, and it's probably not going to be too necessary to have the schematic for this board, but it kind of helps to figure out what's going on with like the other stuff here. One other thing I did is, while I was at it, I didn't make a schematic of this board because these 2 amplifiers, I mean, you can look up the data sheets and they're fairly easy to figure out. Oh, these inductors that are here, they're not really fully inductors. It's actually a resistor, and then it has like a copper wire wound over it, so they're kind of like little filters. So anyways, I looked up the data sheet for the amplifiers, and that way I was able to figure out how the pinout of these 6 pins right here is. And what it looks like they're doing is, it looks like this is J1 right there. As you can see, it's marked J1, and down here is J2 if we're looking at it like this. So it looks like pin 3 up here might actually be used as a low impedance detection switch. So if there's like a short on the speaker outputs or whatever, then this would, the signal that's being applied to this pin would go to the rest of the preamp, and then it knows that, you know, there's a problem out here, and it probably puts it in a protection mode. They got these 100K resistors here, and each one goes to a positive pin, and then the other side is, they're tied together, and then it just goes straight into that pin 3. Pin number 2 on both of the pin headers are ground, so those are tied together. The first input on J1, that's the input for the first amplifier up here, and the first pin on J2 down here, that's the input for the second amplifier. And then the third wire here for mute, that goes to both amplifiers through a resistor, and that's for like shutting down the amplifiers and disabling the audio. So that was fairly easy to figure out. I did not find any shorts on this board, like any of the outputs from the amplifiers, like, you know, directly to like the power lines or whatever. So that kind of gives us another clue as to why these fuses may have originally blown. See, originally I mentioned that there was a 3-pin header or a 3-pin cable going to this connector down here. Well, this connector is wired directly to these capacitors. So if these fuses blew, and it's not because there was a short on this board, it's probably because there's a short on the board these pins go to, which is the preamp board. So we're gonna have a poke on the preamp board and see if there's any shorts at these pins down here, because it's just well, I have it down here at the bottom. The way they're arranged is the center one is the ground, pin number 3 is the negative rail, and then pin number 1 is the positive rail. But let's go back to this board for a second. Let's see how this works, so we can see how these pins here affect why the relay here shuts off. So there's really not a whole lot of complicated stuff going on here, as I already said. The line comes in, it goes through a fuse here that's marked 10AH, and that's a 250 amp fuse. It goes through a thermistor, which is what this big thing here is. So it's kind of a protection thermistor. That goes, the output from that goes directly to that first transformer that's on sitting on that board, and so does the neutral line. So this transformer is always powered on. When this unit's plugged in, this transformer is putting out power. The other line goes, or from the live here, after it goes to that thermistor, it goes to one of the contacts on the relay. The other side of the relay goes directly to the transformer, but I mean, we had already seen that from a little bit ago. Okay, so the secondary of the transformer goes through another fuse up here, then it goes through that bridge rectifier section. The negative comes out, and the negative and the positive are each tied to one of the AC lines here through a 0.1 microfarad capacitor. But say the negative comes down to here, they both, the positive and the negative, both go through a 16 volt 100 microfarad capacitor. So as long as this thing's been plugged in, this capacitor here is going to hold a little bit of a charge. And if this fuse, or not the fuse, this the switch, which is funny on this board, the switch is actually marked J1 like it's a jumper. So if this switch is off, there is like no power going to like any other part of this circuit here. The negative does kind of go off to here to the ground pin on the 3-pin connector, but that's kind of expected because I mean you gotta have some sort of reference for the other 2 pins. So if we click the switch on, then we apply a negative to the other side of this the LED, which is the power LED, through this diode here. And with the way it's arranged here, it looks like that might be a Zener, but I didn't see the numbers because they kind of wrap around. So, but it's not too necessary to know these anyways right now. The positive side of the LED goes through a 470 ohm resistor directly to positive. So as long as the switch is powered or is clicked on, this power LED is going to be on. So that's kind of a given with the way this is wired here. The other side of that switch goes through also another diode, which is D5 here on the schematic. And the way it's arranged is it provides a ground signal over, or the negative from this rail here, over to the transistors. And it goes to the emitter of both of these transistors. The positive that comes over here goes directly to the relay. The other side of the relay goes directly to the collector of Q1 down here, which is the first transistor. There's also a diode here for suppression across the coil right there in the relay. So when we first power this up, if we look at this section of the circuit over here, this is the protection section of the circuit. There's also, I labeled that pin right there, protect. This is the active one, but let's there's nothing hooked up here at the moment. So we apply power. We get ground to here. This positive that's tapped off of here goes through this section, and it goes through all 3 of these. So it goes to the positive of the LED right here through this 470 ohm resistor. Goes to the positive of this capacitor here. There's a 16 volt, 10 or 100 microfarad, and then there's a 1K resistor. So since this capacitor here is not going to have a charge, we're basically going to get a positive at this pin of the base of the transistor through a 10K resistor, which is going to allow current to flow to the relay. So it's going to click the relay on, and then the relay is going to be powered, and that basically keeps the relay powered up after it's on, and like a little bit of current can probably flow through that LED there, but the LED is not going to be on because there's not enough current apparently. If we were to get a signal here at the protect pin, and it looks like it's going to be like a negative going signal, it's going to shut off this transistor. We're not going to get a current flowing through this anymore, so it's going to shut off. Since we'd be getting more of a positive at this point through this diode, this transistor would latch on, basically keeping this transistor hooked up to ground, and that way you can't have this thing like turn on by itself anymore. So this transistor here basically latches this whole section of the circuit off, so that the transformer, the power transformer for the amplifiers, can't get power anymore. The active line coming here from the preamp board just goes through a diode, and then it goes through a resistor, and then it goes to the active LED. So this will actually only be active if this section here is grounded as well. So if this transistor is conducting, this LED has a negative on this side, and it would have a positive on this side. So that's how the active LED would turn on. And since it's not turning on, you can tell that there's no negative over on this side either. So to just sum it up, it looks like the active here gets a positive signal when the preamp board is allowing everything to function, and then the protect, if it gets tied to ground, it looks like that's when everything shuts off, which at the same time also allows this LED here to turn on, because now we have a negative here and we have a positive here on that side. These 3 pins were the 3-pin connector that goes to the amplifier board, the 3-pin connector down there for power. That's where it comes in. But we saw that even though we turned it on and we were getting power to the amplifier and everything, that the fuse didn't blow again. So it's possible that whatever initially caused those fuses to blow may have either completely like blown open or something else. I don't know. But I thought we would check these and see if we're getting any like continuity straight across them or anything. So remember, the middle one was ground. 7.5 megohms there across one of them. Across the other one, 2.27. So it doesn't look like there's any direct shorts there either. Alright, we're just gonna remove this board and take a look at the other side, see where these traces go. They're probably, some of these are going to go to like the regulators. Like I mentioned, there is a transistor here. I don't know if that's being used to power this whole thing up or not. Maybe it's used as another regulator. I'm not entirely sure. So until we pull this out and see what's on the other side, it's kind of hard to tell. So it looks like we've got 8 screws holding that down, plus a few nuts here on those regulators and that transistor. I don't think there's anything else on the back. Nope, that should do it. Alright, so now this board is out, and as expected, there's really, I mean, all that's in here is just stuff for like op amps. There's like no other circuitry really, like no logic or anything, like nothing digital. There are some transistors like down in this area. There's like one here, one here, one here, that one obviously. What I really like about all this stuff inside of this amplifier is that everything's like modular and it just easily unplugs from the other stuff. There's nothing to really, well, there's really nothing I've had to desolder so far. I mean, except for the transformer and the relay, but that's just because I wanted to, you know, get in there and take a better look at all that stuff. But everything else, yeah, just plugs in to these connectors. So I could, I suppose, like put this back on and check some voltages that way, although, you know, these regulators are going to get pretty hot, so that might not be the greatest idea unless I put like some sort of a plate on there. But I guess what I could do now is, now that I see, you know, these transistors here, I can see what they are, and I can check them to see if maybe one of these transistors is bad or something, cause something else to fail. I can check this one. The regulators, I may have to pull them out of circuit to test, make sure those are working properly, but not entirely. I'm going to start with the transistors and check those first, and maybe trace to see where the power lines go. There's nothing that's like, you know, burnt or that looks obviously bad, so nothing visual at least. No, I need to back up a bit. The input for the power is this one right here. My bad. The one over here, that's the one that goes to the input board. So yeah, a little mistake in there. I was like, wait a minute, where's the other connector? Yeah, that's because, yeah, I was wrong about that. But another thing is that these right here, these 14-pin devices, these are, they're not op amps. Those are LM339 comparators, quad comparators. So the op amps are these up here, and those are JFET op amps. Those are LF353Ns. So anyways, I checked this connector here to see if you know, it was shorted to. They're still not shorted, so it doesn't look like anything's directly shorted here at this point. But I might still need to check these regulators. I've mounted the input board back onto this metal plate, and while I had it out, I went through and I checked to see what the pins here were connected to, like on this board, just kind of quickly there. I didn't really want to, you know, go into like a whole lot of detail or like reverse engineer this entire board. Well, I guess, you know, you could do like one section and basically it's like 6 of the, you know, the same thing. It was just kind of a matter of, you know, like seeing where these went to some of the stuff over here to see how they interface to the other connector here for the front board up there with the relay. So basically this is what we've got. Pin number 3, which is the active pin up here that turns on that active LED. It goes directly to a resistor, and I didn't get the values or anything, but that's like R131, and then that goes to Q8, the emitter, which is that big, the transistor right here, the little power transistor mounted on the plate. And then the collector goes to the V+ line coming out from the positive regulator. So this is the positive regulator, and that's the negative regulator. So it looks like when this switches this on, oh, and there's another line that comes out from here and it goes to this board, so the little switching board. So that's got something to do with powering up the rest of the stuff on here most likely as well. I didn't go into that much detail, as I already said, but it looks like that's kind of what that's doing. So when this thing is switched on by something having to do with this board here, whether it's the constant on or the remote switching or whatever, then that also allows power to go through and light up the LED in the front. The protection side of the pin goes to a diode, that goes to a resistor, that goes to another transistor, which is marked Q1, and that's just like a little TO220 device. I think it was an MPSA06, I think that was. So that goes directly to the collector, and then the emitter of that transistor goes to another diode through a 0 ohm resistor, so it's basically just a jumper. And then it goes to two capacitors, two 33 microfarad capacitors that are hooked up in like the positive side this way, the two negatives are connected together, and then the positive side of the other capacitor goes directly to pin 3 on the amplifiers. So I didn't see where the base actually, the base of this transistor actually goes, but what it looks like is happening here is possibly this is getting like some sort of a phase signal from, you know, whatever is coming in, and if this happens to let some current go through from this from the protection pin on the amplifiers, then that's when it triggers this circuit to, you know, to deactivate the relay, and this basically latches on so that it can't be powered up anymore and the protect LED turns on. So another thing that was also on this board that I didn't catch at first is that there's two NE555s right here. And I think what these might be doing is they're doing some sort of timing for the protection, you know, so it triggers like in a certain amount of time so that something else, you know, doesn't happen, something doesn't go completely haywire over here and like end up frying more than it should. And then the other one, I think what that might be doing is setting like a certain time limit for when the power on times out, because I mentioned before, there's an audio sense trigger that you can set. So when it detects audio, it allows the unit to power up. You wouldn't want that like switching on every like few seconds, you know, so that probably, it's like a one-shot type thing that it detects an audio signal, it triggers it, it'll stay on for a certain amount of time, and then if it doesn't detect any more audio after a certain period of time, then it shuts everything off again until it detects some other audio. You wouldn't want this, like, you know, it detects audio, turns on, turns right back off if it doesn't detect anything like right away, and you know, that would be fairly annoying. And I also looked up to see how these dip switches worked. I looked up at the manual. So basically this is, they call it the bus matrix. So what it's doing is we've got 4 dip switches, and you're able to select if these basically select between these inputs here, the main bus input, or the input on the amplifier section itself. So since this one here is set to on the 4th switch here, that means that this is going to be the input, and you can only select one at a time. So you would turn this off if you wanted this particular channel to output audio that's coming from the left channel on the main bus input, then you would select that first switch like that. And if you wanted it to be the right, then obviously it would be the next one down. Or if you just want it to be mono from both of these coming in, then this kind of like mixes them together, and then this particular channel would output mono from both the left and the right on the bus here. So that's how that works. It's pretty straightforward once I actually looked it up. Now that we know the LED protection pins are all tied together, I mean, there's continuity across them all the way across that go to those capacitors that I showed you over here. I think what we could do is eliminate this amplifier, because even though nothing really measures shorted, we can't completely dismiss that there might be that there's nothing wrong, you know, with one or both of these two modules. There could still be something wrong there, and it just, like, say latches up or something once power's applied, and it, you know, one of the output transistors like just shorts everything or something. So I am going to leave this one out. The cable that's here is long enough to connect to this amplifier, so then I'm going to reconnect this one to the input, the power input on this board. I could check the voltages here, make sure that, you know, these are proper. I think they're supposed to be like 18 volts, so I could check to see if, you know, I am getting 18 volt outputs on both of those. Like, one's supposed to be negative, the other's supposed to be positive. I can reconnect this wire that goes to the front board, which I've already remounted, and I also fixed the connectors on there so that they're not all loose on there. I'm going to put this the back input board on the amplifiers. I'm going to apply power, and when we switch it on, if it detects no problems from any of the other amplifiers, or if there's no other problems on this board, because I still don't know. I kind of checked, you know, transistors and everything, and nothing seems shorted. Like, these are not shorted. This transistor over here is completely fine. So I wanted to just eliminate this one just for now and see if it still goes into protection. If it does not go into protection any longer, then that possibly means that one of these or both is bad, and, you know, replacing it's probably going to be the best way to, you know, get this thing working again. So let's see. I'll put this back on and then we'll test it again. Trying to get all those pins from the amp modules here to line up with this backboard was a bit of a pain, because they're all kind of, you know, they could kind of move every which way, and they're all not all lined up perfectly. So I had to kind of start at this end and then just kind of tilt it in while I, you know, align the boards, and then finally got them in. But it should be fine now. So let's go ahead and check and see what it does without the first amplifier board connected. It's not on just yet, so we're gonna click it on here. I have it plugged in though. Now let's see what it does, and let's move this light away a bit so we can see the LEDs. Alright, so let's hit the switch. Nothing bad should happen, because the only thing we did was remove the one amplifier board. So let's click it on, and still nothing. Still goes into protect. Be cool if we could test one amplifier at a time. I mean, I suppose we could. I mean, I really don't think, just by looking at the way things are wired here, we should be able to test individual amplifiers. Well, something else we could do. I could just remove like the screws on the bottom, the screws from the top, and then just try two at a time. And if we stop getting problems with, you know, like a certain set disconnected, then we can narrow it down to one of the two. But yeah, that's let me see. Oh, you know what? I didn't have the switch, the back switch here to constant on, so maybe that makes a difference. Let's see if that does anything. I don't know. Nope, it still tries to power up, and then it goes straight into protect again. Alright, let's do that. Let's see if we can narrow it down. Maybe it's not that first one, maybe it's something else. So, oh, I did say we were going to check the voltages on this board. Well, shoot, the problem is we can't really do that if that's not staying on, because then this relay is not on, so that the transformer is not operating, and then this isn't getting anything, so that's not going to do us any good. Change of plans. Since there's really no voltage going from any of these pins to the backboard, if we just disconnect power to it, I think that should be about the same as not having it connected at all. So let's give that a shot. I will disconnect all but one. So I will leave only well, it'd be the second board over here connected, and see if that triggers anything. Okay, we'll just make sure those don't touch anything. Alright, let's plug it back in. Alright, now let's see what it does. Hey, it stayed on for a sec. Actually, it's still on. Hey, there we go. Okay, so the problem looks like it might be on one of the other boards. Although that still doesn't explain why the first one had the fuses pulled. Now, since it's on, let's reconnect one board at a time. And, well, first of all, let's shut it off. Okay, let's reconnect the next board. And now let's give it another shot. Give it a sec. There it goes. So it seems like it's got a little bit of a power on delay, so that probably has something to do with one of those 555s as well. Okay, so 2 boards. Let's check the third one. Well, I mean, we still have the other one out of circuit here, but so we've got the second one, the third one. Let's check the fourth. Okay, the fourth board. No protect. It should turn on in a sec. There it goes. Okay, sweet. That's 3 out of 6. Let's plug in the 5th board. No. Ha ha. That seems like it's going to be a problem. Okay, let's disconnect the 5th board. Let's connect the 6th board, and we'll check that one. Oh, is it going to do it? No, it went into protect. Okay. So it seems like there might be a problem on the 5th and the 6th board. So let's disconnect these. I'll add the 1st board back in, I'm going to put this one back in, and we'll see if this one has any issues. I thought I was making it easier on myself by removing that top bracket and removing the screws on the bottom of this heatsink to try to pull these amplifiers here, but because the toroid's in the way, I can't pull it out. I can't like bend it out this way. I really can't do anything, so I'm going to end up having to remove the back panel again. These two would have been easy. I mean, this one here, you know, I suppose I could still bolt it from the bottom and then just pull it out backwards, but the first one I can't. And all I wanted to do really was just put the other amplifier back on so I could check that. But yeah, looks like I'm just gonna have to undo this board again. I mean, I could just take the two screws out of these and then be able to move this whole board to the side, so that way I don't have to worry about realigning these. But I guess it doesn't matter, because if I'm going to be removing these two anyways, oh whatever, I'll just pull the back plane off. Okay, I've got all 6 amps back in, and I only have the first one reconnected, and I switched the power wires for the backboard here to that first amplifier. So let's switch it on and see what it does. And hey, no protection. Sweet. Yeah, it went straight to active. Okay, so it appears that these two are the only ones that have an issue. Let's reconnect everything but these two. And we could actually, we should be able to just like test it with audio and see if we go. Well, let's leave these two disconnected. I'll leave these two disconnected again, and there shouldn't be any issues. And no protection again. Okay, and it went back to active. Okay, cool. We're getting somewhere. Let me just try this one more time. There, I reconnected amplifier module number 5. Up, straight into protection. Amplifier number 6. Wait a minute. Oh yeah, there you go. Straight into protection again. Okay. Cool. Alright, so I'll leave these 4 connected, and I'll apply input to these 2 pins here. I could actually do the bus. I could just do like the left and the right. So that way they're all in mono, and I can apply an audio signal here, and I can hook up some speakers and see if we are getting anything from all 8 of these on this side. I hooked up this tone generator that I built some time ago. This here just adjusts the frequency, and this adjusts the output volume. And I just have that hooked up to the bus input. I've set all these to left and right mono, and check this out. It's powered up right now. We are getting a tone from every single amplifier. Oh, that battery's dying. So that's why it's getting lower as I go down. And it's just about dead. Lovely. That was totally unplanned. So the battery in this thing just died when we got to the last one there. How coincidental. Oh man. Alright, well, anyways, so we can confirm that all 8 of these amplifiers are working. So I'll just pull out these 2 and we can take a look at those. It looks like we've narrowed down the problem to this section. Man, nothing is easy. You see how this capacitor down here, that one right there, kind of has a bit of a gap between this heatsink and the top of the capacitor? Well, not so on this side. This heatsink here is a little bit shorter, so that capacitor kind of overlaps with that heatsink right there a little bit. So I can't just straight pull it out, and I can't make it go over this way anymore because it's touching the wire there already, and it's kind of, well, I mean, this is a zip tied down, so it's kind of pinched in there. I can't tilt it up, and so well, I ended up having to undo the screws on this one. I think I might be able to shift it over just enough to get this to slide out. Not really, because oh, there it goes. Okay, now I got it out. So that was a little bit more work than, yeah, you see that, than I was expecting there, but not a big deal. Okay, so now this is out. Time to go investigating. I've taken a look at these boards, and this one right here is board number 5. And look what I found. Around these amplifiers, the board is a little bit dark. I don't know how well this is going to come out in the video, but this section of the board where the amplifier is certainly much darker than the rest of the board. Also on this side. And if we look closely, it's not as visible on this side, so let me flip it around. There's the other side. It's kind of hard to keep in focus, but a lot of these solder joints are really bad looking, like they're kind of cracked around the edge of the pin. Right there, you can kind of get a pretty good view of it right around that one right there. That's a little bit more in focus right there. You can see how they're pretty cracked around the pins. So possibly that maybe there's just some bad connections going on here, just from, like, you know, heating and cooling of these amplifiers. They could have just cracked the pins, and maybe these amplifiers on this side were working a little bit harder than some of the other ones, and that's why these are the ones having problems. And this is amplifier board number 5. If we look at number 6, one of the amplifiers looks kind of okay. This one here looks fairly okay. It's not too discolored or anything, but the one on this side also has a little bit of darkness on the board. So it looks like this amplifier, which would be U1 on this board, this is U2, wherever that is. Anyways, yeah, this one's not as bad as the one on this side. And if we look at the opposite side of that, the pins are also a little crusty looking. So yeah, there are no direct shorts that I could find, like it with any of the power pins or the output. So what I could try doing is reflowing all the pins on these amplifiers and then popping them back in and see if anything changes. If it turns out that it was just bad contacts on a bunch of these pins there, then, you know, this would pretty much solve the problem. And in that case, you know, might as well go through the rest of the boards and just reflow everything, add some fresh thermal paste, and that way, you know, we know we're not going to have some issues anytime soon. Okay, so I reflowed every pin on amplifier board 5 and amplifier board 6. Well, every pin, I mean like the little amplifier ICs themselves. But before I hook these up, we were going to give this another go just to make sure that everything is still operating properly. And I'm going to set the volume on the little tone generator here. I replaced the battery, so we should have no issues with that now. So let's turn this on and see if it's still working as it was. I'm not sure if I'm going to be able to see the LEDs from here. I think I should be able to. Let's see. Okay, green is on. It turns off. The protection one hasn't turned on. There we go. Active is on. So that's still working. Okay, let's go ahead and turn on the... Well, let's hook up the speaker to amplifier 1 here first. Okay, I'm getting a tone from 1, 2, 3, 4, 5, 6, 7, and 8. Okay, let's turn it off. Now we'll hook up amplifier number 5, well, module number 5, and let's see if this works. Nope, it went into protect. Okay, so no good there. Maybe that amplifier is bad after all. And let's go to pin or amplifier module number 6. So we'll leave 5 disconnected. We're just going to hook up 6. No, protection came on again. Alright, so yeah, it looks like one or more of the amplifiers on each one of those boards there is still having a problem. I don't think it has anything to do with the inputs here, although I guess we could check that. I'm just going to make sure, let's move. Yeah, this really shouldn't have any, effect on this. But let's check, just in case. Let's see. So let's hook up, well, let's disconnect 6. We'll hook up 5 again. Nope, it went straight into protect again. Number 6, let's check that. See, number 6 is funny. Number 6 takes a little bit longer to hit protect than number 5 does. Number 5 like immediately goes back into protect. Okay, so there's still something wrong with those. Somehow I gotta be able to check each amplifier separately. This is where the little thermal camera might come in handy. What I could do is take off these modules. Well, I can pull them off the board here, apply power, and check them with the thermal camera and see if which one of these is, I mean, one of them is probably going to get hot. One or both, you know, if they have an internal problem. So they're probably going to get warm, and we might be able to see which one has an issue there. So as long as it's not connected to this backboard, it should not give me any errors in the front. So let's see if that's true. Okay, from this top-down view here, I've got amplifier board number 5 connected, and I've got the thermal camera powered up there right now. What can we see? See, this is one of the amplifier ICs right here, and that's the other one. Okay, so let's power it up. I have a feeling the transformer is probably going to hum away for a little bit, so I'm not going to keep it on for very long. Just enough to see if we get a temperature change there on those two amplifiers, or see if one of them gets hotter than the other. So here goes. It's on. I can hear the transformer humming away, and okay, the one on the left there seems to be getting pretty warm. Let me touch it here. See. Not warm enough to be able to tell that there's much of a difference there, but it does look a little warmer on the... Or actually, you can't really tell. It's a little disappointing. Let me run it for a little bit longer and see. I mean, the fact that it's on that big old heatsink probably doesn't help anything. So let's turn it off. Okay. I don't know if that's warm from me touching it. Let's see if I touch the other one. Yeah, it makes it a little warm. Maybe I should take it off the heatsink. Okay, I set the board on top of a little plastic box there, and the two amplifiers are right here. So I'm going to try to see if I can aim the... I'll put the crosshairs like right in between the two amps. So right there. So there's amp 1, and then there's the other amp right there. So let's power it on, and let's wait for this thing to recalibrate first. Or I guess it's not really going to make a difference. Okay, I got the 2 amps right there. They're kind of diagonal, but let's power it up and see if one of them starts getting warmer than the other. I'm going to have my finger on the switch just so I can shut it off if one of them starts getting too hot. So here goes. Yeah, you see the one right there on the left? This one? Yeah, that one's starting to get pretty toasty. Well, I mean, yeah, you could tell. I could feel that this one's a lot warmer. It's not like baking or anything, but this one's a lot warmer than this one is. So that's the one that has the discoloration on the... Actually, both of them do, but that one has more discoloration than this one does. So I think that might be our problem on this board. Now let's try board number 6 and see what that one does. Okay, now here's board number 6. It's kind of hard to see them through this thermal camera, but we're going to be able to see when they start warming up. I've got the crosshair right there. Can't see it, but it's kind of sitting in between the 2 amps right there. So let's power it up, and I'm going to keep my finger on the switch just in case I need to shut it off right away. And here goes. And whoa, both of those seem to be warming up at the same rate. So I think they both have problems. Okay, I'm shutting it off. Alright, well, I guess that might answer that question. Yeah, they're both feeling fairly warm already. I mean, they're not like cooking right away, but they are getting fairly toasty. According to this thing here, they're just under 30. So let's run them for a little bit longer and see how hot they get. Yeah, that's steadily climbing. It's already going to hit almost 30 there. We're already past 30 on that one. Yeah, they're warming up fairly quickly. So I think both of these are gone. Well, I guess that means I got to order at least 3 of these amps, because it's not like I have these on hand. Alright, well, I guess that gives us a good idea. So it seems like both of the amps on this board are bad and the one over here is bad, but since I have no idea what condition this one's in, I'm just going to go ahead and replace all 4. And in the meantime, while I'm waiting for that, I'm going to just resolder all the pins on the other amps over here and put new solder paste and everything, and just get these, like, you know, just cleaned up in general, and then reinstall these. And then once I get the 4 here, I'll reinstall the new amps and you know, reinstall everything, and it should be okay, it seems, because it's not like there's really much else in here that's bad. So that should do it. So in the meantime, guess I just gotta wait. Amplifiers like this, to remove them from the board, it's kind of a pain because there's so many pins, and on these you can tell that they're like super close to the board. So even though if you try to like get as much solder as you can out of the pin, usually there'll be like a little bit left underneath it, which is kind of hard to get. But since I'm pretty sure that all these are bad, or at least these two on amplifier number 6, the easiest way that I've found to do this is to just break their legs just by bending them back and forth like this. And then once it breaks off, then you can just remove individual pins one at a time, and it goes by fairly quickly and easily. So I'm going to do that to both of these. And now all I have to do is just heat them up and take out one pin at a time. On amplifier module number 5, I've already removed one of the amplifiers, as you can see, but I left this one here. This is the one that I think might be okay. And even though I'm going to replace it anyways, I just want to test and make sure that it does work. I just want to see if it does work. I might just pull it out and keep it around for like backup or something. And now here's the new amplifiers. I just got these from DigiKey about a day ago, and they came out to like $6 something a piece. It was a total of like $33 or something like that after shipping and taxes and all that stuff. So here's all 4 of them. So I got the board number 6 already ready to go, so all I got to do is plop these in, solder them in, and we can test that one. This one here, I still haven't installed it. I want to make sure that, or I want to test that amplifier like I said previously, so we're going to go ahead and do that. When I was taking the amplifiers off the heat sinks, I numbered all the amplifiers so that I know which one, goes to 1, 2, 3, 4, 5, and 6. And I thought I would also number the heat sinks because it would make it easier to know that 5 went here and 6 went here, 4, 3, whatever. Well, it turns out, you can see right there where I kind of numbered them in permanent marker. It's just a 1, there's a 2, and then there's a 3 over here. Turns out that was kind of unnecessary because they already did that. There's a little dimple right here. It looks like it's been done with a punch. You can see right there, there's 2 dots. And then there's 3 on this side. So they're already numbered. So that's some pretty good, nice attention to detail there. It makes it much easier. And that way I can just wipe the whole back off. I'm going to clean everything with like alcohol and everything. You see there's like dust right here. All kinds of stuff. Clean all the old paste off, put some new paste. And after that, I'm going to be ready to put the amplifiers back on. One other little quick thing here that I noticed while I was putting in the new amplifiers. The amplifiers are like right up against the back of this board, as you can tell. And that's obviously so that they can make contact with the heatsink. Well, they kind of put them in a little ways where the edge of the amplifier there, the back of it's like almost flush with the edge of this board. And I didn't realize that when I put this one in. So what I did to the next one here, because I installed this one first, what I did to the next one is I like physically, before I soldered it in, I kind of like bent it a little bit so that I would get a little bit more room out there. You can kind of see how it like sticks out from the edge of the board, and this one just barely does so. It's just a tiny amount. I just didn't want to risk the edge of this thing here making contact with the heatsink and kind of not allowing full contact to the back of that to the little mica insulator there. So just a little thing here, if anybody's working on one of these here, just watch out for that. Well, now here's something a little interesting. If we look at these 2 heat sinks from number 1 and number 2, they look pretty dark and black, the anodization here. So it looks pretty good. On heatsink number 3, it looks really light, and you can kind of see it's a little bit darker right here where the amplifiers were. And that usually happens when the heatsink has been like subjected to quite a bit of heat from what I've seen, like in past things. So that's definitely a clue that these amplifiers were getting quite hot and these other ones were not. So yeah, that's I thought that was kind of interesting. I don't know how well this is going to turn out in the video, but I can kind of see it through the viewfinder. So I think that's that's crazy. All right, we're going to check that second amplifier on board number 5. As you can see, I have it sitting there. I have not put it on the heatsink because I'm not going to test it for very long, and even though generally it's not a good idea to run amplifiers like this with no heatsink, it's only going to be on for a few seconds, and I just want to see if it puts out any audio or if this thing goes into protect. So it's going to be this output right here. I already have the tone generator hooked up, I just got to turn it on. And let's see if it goes into protect first of all. I have power. Let's see. Nah, it goes into protect. So I guess there's something wrong with that one after all. Oh well, out it goes. Alright, it's going to be the moment of truth here in a minute. I've got all the amp boards are reinstalled on the heat sinks on amps 1 through 4, or modules 1 through 4. I reflowed all the amplifier connections, and even though they didn't look bad before, now they look really good. So I'm happy about that. And here's the new amps on these two boards. So I'm going to go ahead and reinstall everything into the chassis, and then we'll fire it up and see if this was successful. I'm extremely confident, maybe like 37.73% or something, I don't know. All the amps are now reinstalled into the chassis here, and before I connect 5 and 6, I'm going to verify that 1 through 4 or 1 through 8 here still work. Or just make sure that the unit doesn't go into protect. No confidence in myself, man. Alright, so let's check that first. If that's okay, then I'll shut it off and then we'll plug in, well, first of all, I'll plug in 5, make sure that that's totally fine, and I'll plug in 6. And they should be fine because, like I said, I didn't see any other problems on the boards. So let's do that now. Got plugged in. Let's power it up. 1 through 8. No protect so far, and active light is on. So that's a good sign. Let's go ahead and plug in 5. Okay, moment of truth. Active is on. And it's stayed on. Okay. Number 6. Active is on and it stayed on, so looking good so far. Now I'm going to plug in the tone generator and we'll check all 12 channels. I've got them all set to the bus here, so that's still the same. Let's go ahead and shut it off for now while I get everything rearranged. We'll come back in a sec. Okay, so I hooked up some alligator clips here to the 2 speaker leads just to make this easier, so I can just kind of plug them as I go. So let me power it up. Okay, now we're on. I might need to adjust the volume on. It's off right now, so I'm just going to plug this into the first one and adjust the volume. Okay, so 1's working, 2's working, 3's working, 4 working, 5 is working, 6, 7, 8, 9, 10, 11, 12. Yeah! Well, I'm really happy about that. That just means that I can put this thing back together now. While I've got this sitting here, I wanted to check this audio sense setting on the amp turn on mode here. Right now, I just powered it up and it's currently active. I wanted to see if that active light shuts off after a while here. So it's been on for, I don't know, maybe about like 45 seconds or so. I'm going to give it a little bit of time. When it shuts off, I'll use the little tone generator and I'll turn it on to see if the amplifier comes on. So I would see, that's weird though, because I don't think it would shut off the relay, because this board in the back isn't getting any power unless the transformer's on. So it seems to me more like it would just put the amplifiers on mute. So if this thing was just sitting there, it would still be like drawing power because of that transformer. Just the amplifiers would be on mute. Only other thing I can think of is that maybe it's just getting like a tiny, like little low-level signal coming from there to here, and that's what's allowing the board that's on the back here to operate. I didn't completely like reverse engineer that part to see how that actually ties into this back board, but it obviously does, because this is what selects when the thing turns on. So I'm just gonna wait a while. It was about 3 or 4 minutes. I didn't exactly start timing the thing, but I just kind of, I started the stopwatch a little bit after I was talking about that. So yeah, it was about 3 or 4 minutes or so before the LED shut off, but I can still hear the transformer humming away. So I thought we would check the shutdown or the mute pin going to the amplifier board and see if we're getting a negative voltage at that pin, because according to the data sheet, these amplifiers, if they get a negative signal on that pin, that's when the amplifier is going to mute. And the mute pin was pin number 3 on J3, which was the bottom 3-pin connector on the amplifier board. So I'm going to connect the multimeter between the ground and the mute and see what it reads. So I've got that here. I'm actually going to use the ground on J2 or J1, which is the top one, and then the mute in, because it'll give me a little bit more room here to set the leads. This is really awkward angle. Okay, let's see. That one and that one. What do we have? Am I even touching the thing? Well, it seems I have about half a volt there. So maybe it's just like grounding it out or something. Let's see. I'm going to turn on the little tone generator. And if it starts outputting audio, I'll check it again and see what kind of voltage it reads then. So here goes. Okay, the active light LED just came back on, so that's working. I'm just going to turn it down a bit here. So now let's check that voltage. And oh wait, now it says, oh okay, no, never mind. I was wrong about that. If it's only active when it gets a negative going signal on this line. So if it's open, that's when it goes into mute. When it gets a negative signal, that's when it goes active. So yeah, so now that it's active, it's reading negative 11 point, almost 11.6 there, negative 11.6. Okay, this time I timed it to see how long it took before it went into standby. It took just under 3 minutes. So that's pretty much basically being done by one of these 555s that was on the corner right there. And now that it's in standby, I wanted to see how much power it was drawing from the wall, and it looks like it's just under 50 watts. So not the most energy efficient thing, I guess. So then also, according to this thing, that's about almost like half an amp right there. It would be nice if it would just, you know, like shut down the big toroidal right here, and it just used a little tiny one there to like power this main or this timing board here in the back. But I mean, whatever. I guess that's how they designed it. With the switch off, and now that we know that we are just using the little tiny transformer up here on that board in the front, it only draws it's almost 2 watts right there, or 60 milliamps according to this thing. So it would be nicer if like this was the standby current when the amplifiers were in mute, but since it's not, I mean, what are you gonna do? One last thing I thought we would check here before we close this off. I've got the phone here generating a 1 kilohertz sine wave. And I'm using the phone because this little tone generator thing that I have generates kind of a crappy sine wave, even though that's what it was meant for. I was using some little IC kit that it's like supposed to be like it's supposed to have like a sine wave, a triangle, and a square wave generator, but the sine wave looks kind of distorted. So if I'm measuring something or I want to see an actual sine wave, I don't use that. I'll just use the phone. So that's on channel 1 right there. That's actually a really clean looking sine wave. Let's go to channel 2 here. That looks pretty good too. I just wanted to make sure that none of these channels had anything funky going on. So that's 3, that's 4, 5, 6, 7, 8, 9, 10, 11, and 12. So as you can see, all 12 channels are working perfectly. I've got the volume all the way up on the phone now, and I've got the meter or the scope here set to 10 volts per division, and we see that we're hitting about 50 volts between peaks right here, and it's still looking pretty clean. So if we put it into bridged mode, we're going to see double that. Oops, wrong one. Oh, actually I can't even bring it down. I'd have to put it in 10x mode over here. So here we go. Yeah, that still looks really nice and clean. So pretty happy about that. So that's going to do it for this video. And as to why the 4 of these amplifiers failed, my best guess is that maybe they were using those 4 channels bridged and they were running like some subwoofers off of them or something, and they just got too hot and they ended up destroying all 4 of those. So thanks a lot for watching once again. If you like this kind of stuff, remember to thumbs up, and I'll see you guys around the bench.